Good morning and welcome back to the second section of Chapter 3. Last time we saw how to solve systems of linear equations by graphing, which is basically guess and check. Today we're going to be looking at using some algebraic methods to solve systems of linear equations. And this is the way we're going to be doing it. Mostly there's two different methods. Both of them will work for any system. Although some systems, one of them will be easier, and other systems, the other one will be easier. And so we will be looking at that as well. Our learning targets for today. I can solve systems of equations by substitution. That's one of the methods. And I can solve systems of equations by elimination. That's the other method. Sometimes it's also known as the addition-subtraction method. So first, let's look by substitution. If we start out with an equation, system of equations, y equals x minus 19 and 2x minus y equals 27, we can see that y equals this, x minus 19. We're going to take that and we're going to plug it into the other equation. So we'll have 2x minus something equals 27. They're just going to plug in what y equals, x minus 19. Now we have one equation with only one variable in it. We can solve this. First, let's distribute that negative to make it minus x plus 19. Then we can combine our x's. 2x minus x equals x. Subtract 19 over, and we get x equals 8. Is that the answer? Does that look like one of the answers we saw last time? No. The solution is going to be a point. It's a point on the graph. We have x. We also need to find y. To find y, we need to plug it back into one of our equations. I would recommend the one that's already y equals. So we know that y equals x minus 19. X is 8. 8 minus 19 is negative 11. So y equals negative 11. Is that the answer? No. Once again, we have to have a point. We have x, we have y, so it goes into an ordered pair. This is the solution. So we can solve by substitution here as well. When we look at this one, 2x minus y equals 2, and 3x minus 2y equals 11, we don't have an x equals or a y equals like we did over here. That's okay. We can get that. We can solve for x or for y. Which one would be the easiest one to solve for? Probably this y right here. Any of the other ones we'd have to divide, and that division is not going to look pretty. It would still work. It would just be a little bit tougher to get through. So to solve for y, 2x minus y equals 2, we can subtract the 2x over, multiply by negative 1 to get y equals 2x minus 2. And then we can take that and plug it into the other equation. 3x minus 2 times y equals 11. Y equals 2x minus 2. And now we have one equation with one variable. We can distribute to get 3x minus 4x plus 4 equals 11. We can combine our terms. 3x minus 4x is negative x. Subtract the 4 over to get negative x equals 7. If negative x equals 7, that means that x equals negative 7. Now we need to plug this into one of our original equations. Or I recommend the y equals 1. It's already there. You don't have to solve. You just have to simplify. So I would plug it into that one. Y equals 2 times x minus 2. X is negative 7. 2 times negative 7 is negative 14 minus 2. Y equals negative 16. Put it in an ordered pair, and that's our solution. Again, we could have plugged it into either of these. We would have still gotten the exact same thing. So, solving by substitution, we get either x equals or y equals. We plug that into the other equation, so we have one equation with one variable, and we can solve for that variable, and then back substitute it into find the other variable. So, you're going to try one now. We have x plus y equals 17, and y equals x plus 7. So go ahead, pause the video, work on this problem. When you're ready, go ahead and push play again. Well, did you do it? Did you get a point? If you didn't do it, pause it, do it. This is part of the learning process. do it so you can see if you can do it before we do it as a class. So here we already have y equals something, so we just need to plug that in. So we have x plus y, which is x plus 7, equals 17. The parentheses here aren't actually doing anything, so we can combine our x's. We have 2x plus 7 equals 17. Subtract the 7, 2x equals 10, and divide x equals 5. Plug that back in. Y equals 5 plus 7, so y equals 12. So the point is 5, 12. Is that what you got? I hope so. If not, see if you can go back and see where you made your mistake. So that was substitution. Solving by elimination is a bit different. Now, it takes about the same amount of work if it's for a problem where it really doesn't make a difference which one you use, but it's split up just a little bit differently. So one of them isn't inherently better than the other. I know that given the chance, I generally go with elimination, but that's just personal preference. So to solve by elimination, we have our two equations, 4x minus 9y equals 26, 4x minus 5y equals 2. We need one of our variables to have the same number in front of it, except one's positive, one's negative. We almost have it here with 4s. We just need to make one of them negative. So let's multiply one of them by negative 1. It does not matter which one we choose. I'm going to choose the bottom one, just because I chose the bottom one. So when we multiply by negative 1, the top's going to stay the same, and the bottom one is going to be negative 4 plus 5y equals negative 2. Now we are going to add these together to get rid of a variable, to eliminate a variable. That's why it's elimination. It's called addition and subtraction because we eliminate by adding or subtracting. And so when we add these together, 4x plus negative 4x goes away. That's by design. We want one of our variables to go away. Then negative 9y plus 5y is negative 4y. And then 26 plus negative 2 is 24. And we can divide by negative 4 to get y equals negative 6. Now you might be thinking, well, it's addition subtraction. We could have just subtracted these two, couldn't we? Instead of multiplying by negative 1. And the answer is yes, you could. However, I caution against that. I would always make one positive, one negative, and then add. The problem with subtracting is you have to remember to distribute your negative to everything. And that becomes problematic. Mistakes get made, especially if you have negative numbers to begin with. If you always make it negative, so one's positive, one's negative, and then add, I see many fewer mistakes. Anyway, we get down here to y equals negative 6. Is that the answer? No, we have to find x. So we have to plug it into one of the two equations. I would use one of the original two equations because the only thing that happens down here is numbers get bigger. So either of these two, I'm going to pick the bottom one just because the numbers are smaller. 4x minus 5 times y, which is negative 6, equals 2. Then negative 5 times negative 6 is 30, so 4x plus 30 equals 2. Subtract 30, you get 4x equals negative 28. Divide by 4, x equals negative 7. So our ordered pair, negative 7 comma negative 6. These two are switched. Negative 7 comma negative 6. That would be the downside to finding y first, but that's the attention thing. That's horrible. Anyway, so you can see how easy it is to make a little mistake here. Having the work behind you, it's like you get down to, negative 6 comma negative 7. I'm looking at it, it's like, oh wait, you have x equals negative 7, y equals negative 6. You got the right numbers, you just put them in the answer in the wrong order. That's not a huge mistake. So, it's one of the importances of work. Another one. So here we have 12x minus 3y equals negative 15. 8x plus 8y equals negative 58. So we don't have the same number like we did over here. It was 4 and 4. Here they're all different. we need to make the same number. We may need to multiply both equations by a number. We could turn the 8 and the 12 into something. Those could both become 24. We could turn the 8 and the 3 into something. Those could both become 24. Does it matter which one we choose? No. I'm going to choose to get rid of the x's, because I would rather multiply by 2 and 3 than 8 and 3. And so both these are positive, so one of them that I'm going to have to multiply by is going to have to be negative. So let's multiply the top by -2 and the bottom by 3. So when we distribute the -2, that'll give us -12 plus 6y and plus 30. And we distribute the 3, that gives us 24x plus 24y equals -174. Now we have the same number, but one's positive, one's negative. We can add these together. When we do, x's go away by design. The y is 6y plus 24y is 30y. That equals 30 minus 174 is -144. Y divide both sides by 30, and y equals -4.8. You could leave it as a fraction if you want. I have it as a decimal here. It's a nice decimal. It's a 4/5, so it becomes just 0.8. So y equals -4.8. That's not a nice number, but we never said it had to be. Most of the time it will, but it is possible that it's not. Let's plug this into the other equation, or let's plug this into one of the equations. So we could use either of them. I would not use these two, just because the numbers are bigger. So which one do we want to use? Let's use the top one. 12x minus 3 times -4.8 equals -15. Distribute the -3, or actually it's not distribute, multiply. -3 times -4.8, 12x equals 14.4. We can subtract that to get 12x equals -29.4. Divide by 12, and x equals -2.45. And so we have our ordered pair of -2.45, -4.8. And notice this time I remembered to put the x first. And look at that. So let's try this one using elimination. We have 2x plus 6y equals -8. 5x minus 3y equals 88. Go ahead and pause this and come back when you are done. How'd you do? Did you get a point? I hope you did. Was it a nice point? I believe this one should be. So let's see, we're going to have to multiply at least one equation, which is going to be the easiest thing to do. We could turn both these into 10, or these could both be 6 by simply multiplying the bottom one by 2. That's the easiest way of doing it. If you did it a different way, that's okay. See if you get the same answer. So let's multiply the bottom by 2 to get 10x minus 6y equals 176. Top one stays the same. We can add them together. This time the y's will go away, and we'll end up with 2x plus 10x is 12x, and then equals 168. We can divide both sides by 12 to get x equals 14. Plug that into one of the equations. Say the top one, those numbers are smaller. 2 times 14, which is 28, plus 6y equals -8. Subtract the 28, 6y equals -36, so y equals -6. Put it into an ordered pair, and we're good to go. And so those are the two methods of solving using algebra. We have substitution, we have elimination. Those are better. Graphing can be problematic. Getting 14 on a graph, your graph is going to be pretty big to get enough detail to get 14. But imagine trying to solve this one on a graph. Your graph would have to be, it would be insane to try and get these decimals by solving on a graph. So let's solve one more system. Let's go 4y minus x equals -24, and 3x equals 12y plus 72. In this case, Substitution is probably going to be easier because it's almost set up. We could get this x, or we could just divide by 3 here. That's what I'm going to do. I'm going to multiply everything by 1/3. That way we can get x equals 4y plus 24. Then we can substitute it in for this x. So 4y minus x, 4y plus 24 equals negative 24. Distribute the negative. The 4y minus 4y is 0. So we get negative 24 equals negative 24. Oh no, look what happened. Our variables disappear. But that's okay because we know what to do when variables disappear. What's left is either going to be true or false. And the same thing is true here as was true before. Some of the vocab is a little bit different, but when it's true, that means that we have coinciding lines. That means that there's infinitely many solutions. We don't use all real numbers here because the answer is an ordered pair. We'd have to have all real numbers comma all real numbers, and that would be the whole plane. We don't want the whole plane, we just want that line. But this would be the coinciding lines. Infinitely many solutions. It's consistent and dependent. If it's false, that means that they're parallel lines, and there's no solutions. So the no solution is the same. It was no solution because they don't intersect. And so that would be the inconsistent type that we saw last time. And so when the variables disappear, that's when you're going to be classifying. And if they don't, if it just intersects, that's the consistent independent. That's what we're dealing with most of the time. But every once in a while, weird stuff happens, and we end up with one of these two situations. So that was section 2. Make sure you do whatever you're supposed to do after this. And until next time, happy mathing.